In this video, we are going to talk about our last type of transformation on the coordinate plane, which is going to be a rotation. So we have previously discussed reflections and translations, and now we're going to talk about rotations. In other words, we are going to be talking about turning. So let's get started. So a rotation is basically, as we see here, it's turning a figure around. We started with a figure in quadrant one. I don't know why the picture is not there. And then we turned it all the way into quadrant four. So it is a turn. It still is the same size and shape, just in a different position. So let's look at which of these could possibly be a rotation. I am looking at these and I'm going to label these A, B, and C. First off, we have A, B, and C. And I am looking here, and as we've been talking about, I want to eliminate automatically ones that wouldn't be like that they just couldn't be. I'm looking at C, and it does not look like that figure was turned. It looks like it was more slid downward. So this would actually be a translation. And so C is automatically out. And then again, I'm looking at B, and that to me looks like a reflection, right? Point B is one above and one below. Point C is two above and two below. And point A is three above and three below. So that to me is looking like a reflection. So by definition, it would have to be A. And we can kind of see that. So we turned all the way from quadrant one into quadrant four, or we could say either way. We either went one quadrant down to the right, or we went three quadrants to the left. So option A is what a rotation would look like. So now I'm looking here, and I want you guys to try to look and figure out which of these would be a rotation. So I'm going to pause in 3, 2, 1, go. All right, hopefully you were thinking number 2. Number 1 to me is looking like a reflection, right? Point F is one above, one below. Actually, no, number 1 could have been number 1 or 2. Could have been number 1 or 2. These were both kind of turned from quadrant 1 to up to quadrant 3. But number 3 absolutely looks like a translation where it was just kind of slid up. All right. Actually, nope, I lied. It still is number 2 because D and E, from D to E should be over, that looks a little bit longer than it should be. So definitely would be number 2. All right, so now that we've looked at what a rotation looks like, let's talk about how to do a rotation. The first thing we're going to do is you're going to be told to either rotate clockwise or counterclockwise. Clockwise goes like a clock, and in the world of the coordinate plane, clockwise would actually go from quadrant 1 to 4, or from 4 to 3, or from 3 to 2. So that's what clockwise would look like. Counterclockwise is how the quadrants go, which would be from 1 to 3, from 2 to 3, sorry, from 1 to 2, 2 to 3, and 3 to 4. So we have clockwise and we have counterclockwise. I'm just going to write CCW for counterclockwise. Okay, each 90 degrees is one quadrant. So if you are asked to rotate 90 degrees, you are going one quadrant. If you're asked to go 180, you're going 2 quadrants. If you're asked to go 270, you're moving 3 quadrants. And here is the best way to remember what a rotation is. You are going to rotate the numbers in your coordinate. So if the point was 1, 2, it then becomes 2, 1, except for when it's 180. 180, the numbers stay the same. So you either switch the numbers if it's 90 or 270, and if it's 180, they stay the same. After that, you pick which quadrant you're in, and then you have to assign the signs. So for instance, if I went from 1, 2 to 2, 1, say I was in quadrant 1 and they asked me to rotate 90 degrees clockwise. That means that I would be going to quadrant 4. So first thing I would do is switch the numbers to 1, and then, okay, I'm going 90 degrees clockwise. I'm going into quadrant 4. In quadrant 4, my x is still positive, but my y would turn negative. So you need to pick your quadrant and attach the sign to your numbers. I know that sounds super confusing. Let's look at what that looks like together. So 3, -2, we want to move this 90 degrees clockwise around the origin. We're going to only be dealing with origin as our point of rotation. So I'm going to start at 3, -2. This tells me to go clockwise. So I'm going to go like a clock, and I'm going to go from quadrant 4 into quadrant 3. So we're going to rotate to quadrant 3. So I plotted my point. I'm in quadrant 3. I'm going to rotate my numbers because it's not 180 degrees. So instead of 3, 2, it's going to be 2, 3. I switch the order of the numbers. And now I'm going to pick my signs. In quadrant 4, so my x would be 2, my y would be, in quadrant 3, both are negative. So my rotated point is -2, -3. And then if you watch the magic, you realize that these 3 points, the origin, our original point and our new point, they form a 90-degree angle, which is why it's called a 90-degree rotation. All right. What is the angle of rotation about the origin that maps the original black triangle ABC to the new blue triangle A prime, B prime, C prime? We only really need one coordinate for this. I'm looking at point A. First thing I need to decide, how many degrees did I move? Point A went from quadrant 1 to quadrant 2. So we moved one quadrant, which is 90 degrees. And we moved counterclockwise because we moved the opposite of the clock. So this was a rotation that was 90 degrees counterclockwise. All right, let's keep working. All right, what is the rotation around the origin that maps JKO to J prime, K prime, O prime? So our original black triangle, JKO, I'm going to look at point J. I went from quadrant 2, and if I go clockwise, I go through quadrant 1 and then to quadrant 4. I moved 2 quadrants. So I made a 180 rotation. Here's the cool thing, and I'm gonna actually go back and I'm gonna go back and point something out about the first one after. It doesn't matter with a 180 rotation. I either went clockwise, I could go 2 clockwise or 2 counterclockwise. So either way, it's still a 180. It doesn't matter clockwise or counterclockwise. So it's just a 180 rotation. A 180 rotation does not need a direction. I want to go back here. So this could be considered a 90-degree clockwise rotation, or it can be considered a 270 counterclockwise rotation, because we either moved one quadrant from 1 to 2, or we moved 3 quadrants from 1 to 4 to 3 and then to 2. So it's either a 90-degree clockwise rotation is the same as a 270 counterclockwise. All right. Last but not least, so same with the mapping arrows, you can say start at one point, map to the next point. Same mapping system that we've been using. All right, we're going to rotate the blue rectangle 90 degrees. Oh, it doesn't say clockwise or counterclockwise. 90 degrees about the origin. So I guess we can pick the direction. I'm going to say, let's go counterclockwise. So we're going to go from quadrant 1 to quadrant 2. My first point, A, which is 1, 2, I'm going to rotate my numbers to say 2, 1. And then in quadrant 2, the x is negative and the y is positive. So my new point would be negative 2, 1. So this is A prime. Now point B, 1, 0. So this is A prime. Becomes 0, 1. I rotated my numbers. And then in quadrant, if actually that's going to be right here. So this is B prime. So that's first. So AB is 2 units. All right, so that's A prime and B prime. Now C to C prime. C is at 5, 0. So now we're going to rotate it to 0, 5. And then last but not least, D. So this is C prime. And then D, which is 5, 2. We're going to flip that and we're going to rotate the numbers to say 2, 5. And then in quadrant 2, which is where we're rotating to, the x is negative and the y is positive. So this is going to be negative 2, 5. And that's D prime. So that is my rotation. 90 degrees around the origin. Alrighty. That is going to do it for now. We will talk about this all together. I know it's a little confusing, but we will get through it and we will talk soon. All right, bye guys.